zero. The remainder is zero. The divisor is a factor of the polynomial. So if when you divide it, the remainder is zero, then whatever you're dividing by is a factor. So whenever you hear remainder is zero, think it is a factor. If you ever hear that something says is a factor, then the remainder is zero. It's interchangeable. So if on a test I ask you, is this divisor a factor of the polynomial? You could either do synthetic division, which we're going to learn today, and see if the remainder is zero, or you could just do remainder theorem and see if the remainder is zero. If the remainder is zero when you divide by it, it is a factor. Okay, that's all factor theorem is. Remainder theorem states that if you take the divisor and solve for x and plug it in, you get the remainder. Factor theorem just states that if you plug that in and you get a remainder of zero, it is a factor. Everyone forgets that when it comes to the test. So if the remainder is zero, it is a factor. So polynomial px has x minus b as a factor if and only if, when you plug in that and you solve for that, you get x minus b equals 0, so x equals b. When you plug that b value in for all the x's, you get a remainder of 0. Then it is a factor. So the polynomial p of x minus b is a factor if and only if p of b equals 0. Basically, you get a remainder of 0, it's a factor. That's all it is. It's not a hard concept, it's just one that everyone forgets. Okay? So we're going to verify that this is a factor. So we're going to verify using remainder theorem. So if you want to verify it is a factor, the instant I read is a factor, I am underlining it and writing remainder 0. Every time. So I read is a factor, I double underline remainder is 0. Every time. I don't even think. I don't even read the rest of the sentence. I stop, I underline it, and I write is the remainder is 0. So I remember that. Okay? So verify that x plus 2 is a factor of this. The remainder is 0. Oh, that's how I verify it. So plug it in. X plus 2 equals 0. So x equals negative 2. If I do p of negative 2 and I get it equals 0, then it's a factor, right? That's it. That's all. How does that concept? And it's a concept you need to know in order for us to factor anything greater than x squared. Okay? So we plug in. We get negative 2p plus 5 times negative 2 squared plus 2 times negative 2 minus 8. And it has to equal 0. If not, we're not verifying this at all. Verify means prove. Prove means show that this equals this. So in order for this to be true, 0 would have to equal 0. So we're going to get negative 8 plus 5 times 4 is 20 minus 4 minus 8 equals 0. Negative 8 minus 8 is negative 16 minus 4 is negative 20. Negative 20 plus 20 is 0. So we get 0 equals 0. We proved it. We verified it. It is a factor. What's a factor? Well, if I factored x squared plus 3x minus 4, my factors would be x plus 4, x minus 1, right? Those are the factors of what I factor. Well, we no longer can just go and factor just an x cubed. We are factoring, but not by product sum or decomp, okay? We'll be using product sum and decomp, so if you can't factor, the next 2 lessons are going to be impossible. So if you're someone who's like, I've just gotten through without my factoring, and I'm going to do, no, it's going to be bad. It's going to be very, 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 very bad. So if that be the case, you should do no BFF until the test, okay? And we need to be factoring until you are like a rock. Okay. So, for example, is x minus 2 a factor? Oh, a factor. Remainder 0. And you're like, man, that remainder is a long word, right? R equals 0. Same time, I don't really care. So, use the remainder theorem. So, we have x minus 2 equals 0, so x equals 2. Plug it in. P of 2. So we're going to get 2 cubed minus 6 times 2 squared plus 3 times 2 plus 10. 2 cubed is 8. Minus 6 times 4 is negative 24. Plus 6. Plus 10. 8 plus 6 plus 10 is positive 24. 24 minus 24, 0. So is it a factor? Yes. X minus 2 is a factor. Sometimes it's not. How could we ask this as a multiple choice question? Which of the following is a factor of this polynomial? X plus 3, X minus 2, X plus 4, X minus 6. Lump them all in and see which one gets you a remainder of 0. Right? All right. And now is the factor. We're going to use synthetic division. Okay? First thing we're going to do, in order to factor this, so this is an x squared, right? So I can't just go what times that gives me what plus what gives me what. Next week. Let's use synthetic division. So the first thing you're going to do is identify the possible zeros. Possible is the key word here. Doesn't mean they actually are, it's the possible ones. The possible zeros of this, you look at the back number, your constant, and you list all the factors of it. So the possible zeros, zeros meaning x-intercepts, right, or roots, all interchangeable, this is x-intercept, or roots, or zeros, all mean the same thing, right? It's just fancy words for the same thing. So the possible zeros are the factors of 6, positive and negative. So my factors of 6 are 1, 2, 3, 6. So plus or minus, plus or minus, plus or minus, plus or minus. Now, in order to factor, we have to find a factor of it. Right now, I have possible 8 different ones that I could try. So what would you have to do? Plug in positive 1. See if you get a remainder of 0. Do you? I don't know. If you do, you're done. If you don't, plug in negative 1. You get 0. If you don't, plug in 2. You get 0. Plug in negative 2. Plug in 3. Plug in negative 3. Plug in 6. Plug in negative 6. So you get one that gets you a remainder of 0. So that's 8 possibilities. If it's 12, that trumps you up a little bit longer, which is 6. So let's think about it. If it is a factor, if x plus 2 was a factor, what if x plus 2 was a factor? Then x equals negative 2 would be my root, correct? Yeah? So what's great about this? Your calculators aren't taking away from your grade. Later on, possibly. Yeah? That's fine. So we're going to use them to its full stability. Go into your y equals and type in x cubed plus 2x squared minus 5x minus 6. And remember, you need to know possible zeros because sometimes the question on the test is which of the following is a possible factor of this polynomial. Possible. And if you plug in every single one of them, you actually don't get a remainder of 0 at all. But it's possible. So if it was 1, 2, 3, or 6, then it would be possible that I picked that. Okay? So it's possible. All right. Plug it in. Now, go second graph. We are looking for x-intercepts, correct? X-intercept means what? 0. Y. So we're going to look for something on that list, hopefully, that has a y of 0. Is there anything? Which one? 2, 0. Okay. So what some people do is they pick the y-intercept. So watch yourself, don't pick that one, right? They pick x-intercept, so 2, 0 is one of them. So if I see that, I'm going to use that one. Now, if it's a different one, you can, that's fine. You can use a different one. But I'm going to just use 2, 0 for G. Okay? Use a different one, you'll still get the same answers, just indirect. So let's prove that it actually works. Let's plug it. P of 2. 2 cubed. Because remember, what do we plug into the polynomial? We plug in the x-intercept into the polynomial, or the x equals into the polynomial. So 2 cubed plus 2 times 2 squared minus 5 times 2 minus 6 equals 8 plus 4 times 2, 8 minus 10 minus 6, which is 0. So yes, x equals 2 is one of the roots. One of the x-intercepts. You proved it on your calculator anyways, right? But I could work through it. I could say p of 1. No. P is negative 1. No. P is 2. And then literally work through until I get a remainder of 0. Or you can use your calculator for faster. Okay? So we proved proof that 2 actually does work. This is my root. So what I do is I use my root in synthetic division. But what I'm going to write above it is the factor. X minus 2 is the factor when x equals 2, correct? Do you agree? So I always write the root and then the factor above it. Because if it tells me the factor, my answers are going to be x plus 2, x minus 3, x minus 4, something like that. But if it asks me to solve, which is the next lesson, solve means x equals. So you need the x-intercept. If you write both, it's very easy to get either today's or tomorrow's answers because you found them both. Okay? Difference between factor and solve. So this is factor. So, synthetic division, we're going to pay attention. We always use the root. We always use the x-intercept. We always use the one that gets to 0 for remainder. Okay? Pay attention. We put a 2 out front. Then we make an L. The L, stop. Do not draw an L. We were doing this in high school and I'm going to erase it or use whiteout. I don't remember who the pen or pencil. But when you draw the L, you need to make it a large L because you're going to have a row of numbers up here and a row of numbers down here. Now people can put a narrow L and then you do pushing or else you're erasing or whiting out. You need to be able to have a big enough L that you can put a row of numbers up here and a row of numbers up here below within the L. Okay? You're going to do 2 rows of numbers. You have a number here and a number here. Now, what numbers we fill in to the top are the coefficients of your polynomial. Now, if you're missing, you fill the count down. If you're missing an x value when you count down, you have to use a 0 placeholder. So, we have x cubed, x squared, x1, 0, right? So we're not missing one. But if I would have had like 3x squared plus 2, in my synthetic division, I would have 3x squared plus 0x plus 2. If I actually wrote it out, and on the top of my synthetic division, I have 3, 0, and 2. So don't forget that if you're missing, why if you can't count down, you have to have a 0 placeholder in its spot. I won't forget that. Okay? These ones I can count down. I have x cubed, x squared, x, no x. So we're good. So I just write the coefficients at the top. So we have a 1, and a 2, and a -5, and then a -6. I forewarn you, this is going to seem overwhelming at first, but it's actually very, 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 very easy. It will seem overwhelming at first. So, the first thing you do, drop down the 1. So draw an arrow, and the 1 comes down. All I'm going to do from now on is multiply, add, multiply, add, multiply, add, multiply, add, multiply, add until I'm done. Literally. Multiply and add, multiply and add. Okay, so I'm done. So 2 times 1, and then I'm going to show this to the first one. 2 times 1, if you want to write this as steps, this is kind of how you do that. 2 times 1 comes up here. What's 2 times 1? Here. So I multiply, and now I add. 2 plus 2 is 4. I've added, so now I multiply. Multiply, add, multiply, add, multiply. So 2 times 4 is 8. I just multiplied, so now I'm going to add. -5 plus 8 is 3. I just added, so now I'm going to multiply. 2 times 3 is 6. And I add, what's -6 plus 6? 0. Your box is back number. This back number in the box is your remainder. So yesterday, we could have found the remainder by actually doing synthetic division. Right? Like I had those synthetic division steps you could have done. Because when you're done doing synthetic division, this back box here is the remainder. So instead of using the remainder theorem, I can do synthetic division. If you're only looking for a remainder, though, remainder theorem is way quicker. Now, not that. This is just weirdly looking numbers. Okay. So I have x minus 2 and x equals 2. That's one of my factors. One of my factors is x minus 2. Yeah? Now, this 1, 4, and 3 come down here. 1, 4, and 3. These are going to be numbers of variables. Because all we did up here was you took the numbers of variables and wrote down the coefficients, correct? Now, what's 1 less than x cubed? X squared. And the reason why this becomes 1 less is because we have this factor right here that we could multiply by that, and if we multiply it by this, we'd actually get the x cubed back, okay? So technically we have a factor right now here, which is x minus 2. And we also have this left over, which we just did. Well, if this is x cubed, this is going to be x squared plus 4x plus 3. You just go down in order of x. So if I expanded these out, I would get the x cubed back. We're not done. I'm asking you to factor it. So you have to break it down into its factors. So right now we have one factor. Excellent. This is grade 10, 11 back again on here. Factoring. We need to factor this to the next squared, right? It's just factoring. So what times what gets me 1 times 3, which is 3. What plus what gets me positive 4. 1 and 3. Now I don't have to do these columns because I have a positive 1 in front, yes? So I'm going to get x plus 1, x plus 3, and I'm done. I factored it. You have to use synthetic division until you can get it down to the next square and factor it like grade 10 or 11. Okay? You see how if you can't factor, it's almost impossible to get the answer. You just need to factor. Now, if I expanded these out, so if I FOIL these two front ones, and then I distributed the extra 3 and collected like terms, I would get this column. That's all I did. It's factored, so I got that. Now, when it says factor, if this you can't factor it, say it's x squared plus 4x plus 2, so there's no way you can factor it, you'd be done. Your answer would just be x minus 2, x squared plus 4x plus 2. If it says factor. If it says solve, you'd have to keep going because you could actually get a decimal root. Decimal intercept. If it says factor, you stop when you can't factor no longer. If I could factor, so I keep going. So these are my 3 factors. Now, a lot of people will give me these 2 factors, but they'll forget to bring this one back down. Come up here. And they'll give me 2 factors, but it's actually 3. How do I know there's 3 factors? Because there's 3 x-intercepts and an x-intercept. They're not like a crazy weird like 1.739. That's crazy. Okay? So this is factoring. I've answered the factoring question. What if I had said solve though? Solve means find x-intercept, which is what we're doing tomorrow. So factor, this is the answer. If it said solve, my answer would be 2, negative 1, negative 3. Difference between the word factor in a question or solve. Okay? All right, you can flip over. Okay, you know what the first are possible ones. What's the possible factors of this x cubed plus 9x squared plus 23x plus 15? What's the possible factors of that? So your constant at the back, and then we're going to factor it. So 15, factors between a 1, 3, 5, 15, and then with plus or minus sign in front of it. So if your calculator was taken away from you, someone came and mugged you and stole your calculator tonight, you could still do this homework. It would be time consuming because you have to go fill in 1 to get a remainder 0. Nope. Fill in negative 1 to get a remainder 0. Nope. 3, negative 3. You have to keep going until you get a remainder 0. So you could be mugged and your calculator could be taken away from you, and you could still accomplish your homework. Okay? But you're not mugged. So plug it into your y equals. Go to your table of values and look for your x-intercept. Whoever says the first one is the one I'll use. There's no anything more. There's no x minus 1, x equals negative 1, or x equals. So we have x equals -1 because that's our x-intercept, -1 and 0. And then we have x plus 1. There may be more. That's what I'm thinking. Did everyone else get -1 in your table? Okay, so we always use our x-intercept. Now, if you are a BFF with Mr. Royce's class, or someone in Mr. Royce's class, it's Mr. Royce's class. If you're best friends with his class, at least listen. If you're best friends with someone in his class and you are doing the homework with them, he uses the factor and subtract. So maybe don't BFF for this unit. And you're going to use BFF away. But it might just confuse you. He'll use +1 and then he just subtracts. So instead of multiplying and adding, he multiplies and subtracts. I just use the root and then multiply and add. Neither is better, it is different. Okay? So I just use the root. So when you plug this into your polynomial and you get the remainder of 0, you use that value and you also use the remainder of 0. Either way, with remainder theorem or using synthetic division, if you use this value here, you will get the remainder of 0. Okay? That's why I do it. So we're going to plot that in front of our synthetic division sign. Then we have to count down, make sure we can count down x1. X cubed, x squared, x numbers. Can we count them down? Absolutely. We don't get any 0 placeholder. So we just write a coefficient. 1, 9, 23, 50. And we're going to drop it down, multiply, add, multiply, add, multiply, add, multiply, add. I think it's your add. So if your BFF is on the math class, BFF away. All right, let me do it from that. So we drop the 1. Then we multiply, add, multiply, add, multiply, add, multiply, add until we get a 0 in the box for the remainder. If you don't get 0 in the box for the remainder, you did something wrong. You either picked the wrong number or you're multiplying and adding a pair. Or you missed a placeholder, which is often the problem. So -1 times 1 is 1. With a negative sign. Then you add them. 9 plus -1 is 8. Then you multiply. -1 times 8, -8. And you add them. 23 minus 8, 15. Then you start getting really happy because you can see that you're going to get a 0. -1 times 15 is -15. You add those, you get a 0 in the box, so you're good. You want to go back. So my one factor is x plus 1, the one I had initially. My other factor is going to be this. 1 less. So if this is an x cubed, I'm going to x squared. X squared plus 8x plus 15. Remember, I have to keep synthetically dividing until I get an x squared. So if I have an x5, I'm going to synthetically divide, it'll give me an x4. I'm going to have to synthetically divide that, it'll give me an x3. I'm going to have to synthetically divide that, it gets me an x squared, and then I can factor. You will never be so happy to see that you can product sum or decomp like you will in this unit, because then it's plus 1. Okay? So, x plus 1 stays. And this is product sum again, because I have a plus 1. So what times what equals 15, what plus what equals 8. And we get x plus 3, x plus 5. And remember, like I said to you, if this can't factor, I'd be dead. That was my answer. I'd box it and write it down. But it factor, so now I'm done. Okay? If it says solve, instead of factor, which it says factor, if it says solve, the answer would be x equals -1, -3, -5. Just one extra step. possible zeros? Plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. Those factors is that number. Please spot that you cannot count now. I have x cubed, I have no x squared, I have x1, I have number. So I need an x squared, right? So if I don't have it, I just write it as 0x squared. You have this one. X cubed plus 0x squared minus 27x plus 10. How do I get what I need to use in my percentage division calculator? Plug up again. You don't have to plug in the 0x squared equation. It doesn't matter if you do. You just say answer to home. Plug into your y equals. You take those values. Look for your x equals. The number and y equals 0. First person getting one. There's an award of the network. That's the other number, not the state. So 5 and 0 is the point. So x equals 5. And my factor would be x minus 5. That's a 5. And then I put my coefficient. The burden of coefficient is 1. I'm going to get 1, 0, negative 27, and 10. If you forget the 0, you will not get a remainder of 0. If you forget that 0 placeholder, you're not going to get a remainder of 0. So often, when people can't get the remainder of 0, they freak out and go grab another number and try it again. Then they can't get the remainder of 0, then think it's something wrong. You are. You're just forgetting to put that 0 placeholder. You didn't have an x squared in the polynomial. You have to be able to count down. X cubed, x squared, x number. So, we got the 1, we multiply, we get 5, we add, we get 5, we multiply, we get 25, we add, we get negative 2, we multiply, negative 10. Okay. So our factor is going to be x minus 5 and 1 less. So x cubed is x squared. X squared plus 5x minus 2. Can I factor x squared plus 5x minus 2? Well, multiply to be negative 2. 2 and 1. 2 and 1 in any way going to add to 5? No, we're up. Okay, go down. You're not going to say that's cubed. Life will change. Let's do the next thing. Grab yourself an x4. We're just going to do E, so if you run over out of space in E and you run into F, I don't really care. So, same steps. What are my possible zeros of 18? 1, 2, 3, 6, 9, 18. And now you're extremely grateful you have the calculator. And you're going to try and look at multiply now. Next thing we check, can we count down? X4, X3, X squared, X number. Yeah. Go ahead and place it. Go to our calculator. Plug that baby in. Give me an answer. First person winning the number. So X equals equals 3, it could be x minus next factor. 3. And I'm going to go 1, negative 3, negative 7, 15, 18. Exact same as we did last time. Drop the 1. 3 times 1. 3. Add it. 3 equals 3. 0. 0 times 3. 0. Add it. Negative 7. Negative 3 times negative 7 is negative 21. Add it. Negative 6. Starting to get super excited. Negative 6 times 3 is negative 18. 0. Wham. Like I said, if you run into F, you take it out, that's fine. Now what do? It starts out as 1 less. The last one was x squared, x number, right? Here it's going to be, if this is x squared, it's going to be x3. And I'm going to square this lovely factor, because at the end I'm going to use that factor. That's one of the factors for sure, right? We can break this down into more factors. So, I now have 1x cubed plus 0x squared minus 7x minus 6. How do I factor an x cubed? Synthetic division, so what do I have to do? Plug it in my calculator, go to the table of values, find me an x-intercept. We're just literally back to where we were on this other question. You just have to do it again. Plug it in and get me 0. So we have another one. That's 3. I'll show you why there was 3. Look at the graph and see if I can plug into your calculator. We'll plug the original one back in at the end. So we're going to use our 3. We're going to use our coefficients 1, 0, negative 7, negative 6. We're going to drop that 1. 1 times 3 is 3. Add it. 0 plus 3, 3. 3 times 3, 9. Negative 7 plus 9, 2. 3 times 2, 6. Add the negative 0. And then this is going to be 1 less. So 1x squared plus 3x plus 2. And I'm going to box this factor, because now I have 2 factors. At maximum, I'm going to have 4 factors, because at maximum, I can only have 4 x-intercepts for next 4, right? But that maximum, I can only have 4 x-intercepts, and then have a maximum of 4 factors. Quite some. What times rectitude 2? What plus rectitude 3? 2 and 1. X plus 3. X plus 2. Oh my goodness. X plus 2. X plus 1. So a lot of people will give me that as their answer and they box it. No, that's why I boxed those babies up there. You need those 2 as well. So you can write this as x minus 3 times x minus 3 times x plus 2 times x plus 1. Or you can write this as x minus 3 squared, x plus 2, x plus 1. And you put things in, get my USD and get my calculator back and actually do it. So, I don't have it. You need to plug it into your calculator. Plug it into your calculator, the original one. Plug it in. Plug it in, plug it in, plug it in, plug it in. Your calculator, if you look at it, it says this. This number here is a 3. Crazy. I have 2 x-intercepts of 3. What happens when I have 2 or 4 or 6 or 8 or 10 or 12 or whatever x-intercept? I get a point of tangency on that x-intercept. Because I hit it once and it bounces back up. So instantly looking at this graph, I know I have 2 there. The graph tells me that. And then it shows at negative 2 and negative 1 it passes through. So in fact, it's already from that. Some people will say, well, then why can't I just go to my calculator and pull the answers off? Well, that's just stupid. Because what they're going to do is they're going to make you do decomp. They're not going to let you do product sum. The moment you do decomp down here, you're going to get fraction. Or when you get a fraction, you're going to get 2x plus 1 or something. What does your table of value not give you? Fractions. So if you're someone who's banking on just like pulling them off the table of values, like every person that I've taught for the last 10 years thinks they're going to do, and doesn't learn how to do it, which you'll still have to do anyway, you're going to get halted whenever you get anything where you have to do decomp of that x squared. Okay? So let's turn to the assignment at the next page, at the bottom of that page. And then we're going to write what we actually have to do because that's just nasty. So page 133. Like, you want to simulate it sometime. So far, 2E. 3E. 4E. At this point, we're 2E, 3E, 4E. Five ACD, no 6. Now, number 7 says, determine the value of k so that the binomial is a factor. Oh, I'm reading is a factor. What do I think? Remainder is 0. They're just indirectly giving you the remainder is 0. You're going to use remainder theorem off the page, just like you did yesterday. But remainder is 0. You have to think when you read as a factor, or this question is like, then you're stuck and you can't answer the question. Okay? Is a factor remainder 0? Is a factor remainder 0? Should be part of the right. 7, 8. 11. You can't complain because there's way more blue stratioti than blue right now. Stratioti. There's a lot of stratioti going on here, and a lot of not stratioti. A little not stratioti.